Welcome to the lecture. From starting 8051 architecture, we were discussing about pin configuration, instruction formats, addressing modes, and serial communications available. Now we have entered into the interfacing. So previously we have discussed about interfacing with LCD, and now we are getting the last topic like keyboard interfacing. So you can see here it is a matrix format, or you can see 4 into 4 matrix interfacing here. This is the interfacing point. So we have rows and columns. So the rows are connected to the output port P0. Here you can see output port P0. The rows are connected, and the columns are connected to the P2, P1 and P2, two ports we have taken here. If no keys are pressed, reading the input port will yield oneness for all the columns since they are all connected to the high. So since they are connected to the VCC, they are all high. If all the rows are grounded and the key is pressed, one of the column will have 0 since the key press provides a path to the ground. So initially it is connected to VCC, so all the paths are 1. If I'm pressing this point, for example, I'm pressing this 9, this particular column will get 0 as it is pointed to the ground. If the function of the microcontroller to scan the keyboard continuously detect the and identify the key pressed. So let us see how it scans the key. To find out the key press, the controller grounds a row by sending 0 on corresponding line of the output port. It then reads the data at the columns using the input port. If data from columns D0 to D3 is equal to 111 and there is no key pressed, if any bit of the column is 0, then it indicates that key is pressed in that column. In this example, the column is identified by the values 1100. Now, the column 0 is pressed. For example, 1101 instance, the column 1 is pressed. So depending upon the 4 columns, if either of the column is 0, the particular column is being pressed. So thus the key is scanned. And steps to find out the key pressed. Beginning with the row 0, the microcontroller grounds it by providing a low to row D0 only. It then reads the columns port 2. If the data read is all 1s, then no key is pressed in that row is activated and the process is moved to the next row. If then grounds the next row, read the columns and checks for any zeros. The process continues until a row with a 0 is identified. After identifying the row with which the key has been pressed, the column to which the pressed key belongs is identified as discussed above. The column is, first we are going for the row. If the row is 0, we are checking for the column. And once it is done, we are concluding that key is pressed. For example, D3 to D0, 1101 for the row, and D3 to D0, 1011 for the column. It indicates row 1 and column 3 are selected. This key indicates that key 6 is pressed. Another example for D0 to D3, that is for row 1011. So it indicates it row 2, right? And for D3 to D0 for the column 0111. So it indicates column 3. So here the key pressed is B. So in this example, we can get a clear picture of how this matrix has been executed, right? Now we are getting into the program. So we have mainly 4 steps. First one, we have to make sure that presiding key has been released. Zeros are the output of all the rows at once, and the columns are read and checked repeatedly until all the columns are high. When all the columns are to be founded high, the program waits for the short amount of time begins before it goes for the next stage of waiting for the key to be pressed. To see if any key is pressed, the columns are scanned over and over in an infinity loop until one of them has 0 on it. Remember, the output latch is connected to the rows, still has the initial zeros in stage 1, making them grounded. After the key presses detection, it waits for 20 milliseconds for the bounce and then scans the column again. It ensures that first key press detection was not an erroneous one due to spike noise. After the 20 microseconds delay, if the key is still pressed, it goes for the loop step 3. So next step 3 is it detects which row key pressed belongs to. It grounds one row at the time, reading to the columns each time. So it finds all the columns are high. This means that key press does not belong to that row. Therefore, it grounds the next row and continues to find until the finds the row. So first it continues with the column and first it continues with the starts with the row and it checks for the column, and finally to identify the key press it rotates the column bit one bit at a time into carry flag and checks it to see if it is low. Upon finding the 0, it pulls out the ASIC value code and the key to look up the table. Otherwise, it increments the pointer to point the next element of the lookup table. So here we can have a glance of the flowchart. Thank you.